Welcome to the Introduction to Drug Dosage Calculations workshop presented by Germanna Community College Tutoring Services. Today we're going to discuss the basics. We're going to talk about the 3 units of measurement, metric conversions, converting between units, drug dosage conversions using 4 separate methods to do these conversions, oral dosages, parenteral dosages, and reconstitutions.
Let's look at the 3 units of measurement. We can use household, apothecary, or metric units. Household units are ones that we use normally in our houses. Teaspoons, tablespoons, pounds, ounces, those types of things. Anytime we use a household number, we're going to write the number as a whole number or a fraction before the unit. In other words, for example, if I had 1.5 tablespoons, I would write 1.5 and then a capital T after it to show I'm talking about tablespoons. The apothecary system is a system that was used a long time ago. It's a very approximate system. We have grains and drams and minims. If we look at a grain, what that really meant was a grain of rice. They would measure out 3 grains of rice to weigh out their medication. As we know, grains of rice all weigh differently now, so we do have 2 conversions that we have memorized for grains. And we need to remember that these are just approximations. Also, because this is an older system, we can't use decimals. We can only use whole numbers, fractions, and Roman numerals. The other difference with the apothecary system is we put the unit first and then the number. For example, I would write grain 15, not 15 grains. I could also write dram 1.5 by using Roman numerals. The third system we can use is the metric system. The metric system are grams, liters, or even meters. And in this case, we can use whole numbers or decimals, and the number always goes before the unit. One thing we do have to remember about decimals, though, is if it's just a decimal with no whole number, we have to put a 0 in front of the decimal. This way, we eliminate any misread medications. We wouldn't want somebody to read 15 milliliters if we actually meant 0.15 milliliters. When talking about metric conversions, there's going to be basically 3 prefixes we need to know plus our bases. Our bases are our base units, grams, liters, and even meters. There's one larger unit to the left of our base unit called a kilo. The smaller units we need to recognize are our milli and our micro. There are 3 decimal places in between each of these conversions. Therefore, to convert from one metric unit to another, we only have to move the decimal point. For instance, if I wanted to go from a gram to a microgram, I would move the decimal 6 places to the right. Whereas if I wanted to go from a gram to a kilogram, I would move my decimal 3 places to the left. We can convert between units, and in order to do this, we're going to have a conversion factor. This way, we can eliminate the given unit of measurement and convert it to a new unit. There are 3 ways we can set up these conversion factors. We know that 1 kilogram is equal to 2.2 pounds. We could also use a colon to show this relationship of 1 kilogram to 2.2 pounds. Or we could write it as a fraction, 1 kilogram over 2.2 pounds. All 3 ways are showing us a true relationship between kilograms and pounds. There are 4 different methods to perform these conversions. We can use the ratio method, and in that method, we would set up our conversion factor with a colon, 1 kilogram to 2.2 pounds. We then would put an equal sign and put in the number we're trying to actually change, such as we want to find out how many pounds are in 12 kilograms. Notice the order of units is the same on both sides of the equation. Our known conversion factor, 1 kilogram to 2.2 pounds, puts kilograms first and pounds second. On the right-hand side, we're putting our unknown, but the units still stay in the same order, 12 kilograms to X number of pounds. Another method is the proportion method. In this case, we use a fraction to show our relationship between kilograms and pounds. On the left-hand side, I put my known relationship of 1 kilogram over 2.2 pounds. On the right-hand side, I'm going to put my unknown relationship. Keeping in mind, I want to put the units in the same place they were on the left-hand side. Kilograms was on top on the left, so I'm going to put my 12 kilograms on top on the right. Pounds was at the bottom on the left, so I'm going to put my X pounds at the bottom on the right. A third way is dimensional analysis. In this case, you start with the unit you're trying to change, 12 kilograms. Then we would multiply by a fractional relationship of our conversion factor, what we know. We know 2.2 pounds is the same as 1 kilogram. However, this time, we're going to put the unit that we're trying to get rid of, kilograms, on the bottom so that the kilograms cancel, and we'll be left with pounds at the end. The fourth way is the formula method. In this case, we take the dosage ordered over what's on hand times the quantity it's being delivered in. Sometimes it's not really a dosage, such as the 12 kilograms we're trying to change, but we put the 12 kilograms over what we know, the 1 kilogram, times what it's related to, the 2.2 pounds. Let's go ahead and try a problem in each of these four methods. First, let's use the ratio method. We want to take 10 kilograms and find out the number of pounds it's equal to. First, we have to find our converting factor, 1 kilogram to 2.2 pounds. Then we're going to set up our problem. We're going to take our known relationship of 1 kilogram to 2.2 pounds and set that equal to our unknown relationship, 10 kilograms to an X number of pounds. Again, notice the order. Kilograms is first on both sides of the equal sign, pounds is second. We then multiply our means and our extremes. And you can do this basically by drawing a rainbow. The 1 kilogram gets multiplied by the X pounds. The 2.2 pounds gets multiplied by the 10 kilograms. We then will solve for X, and we discover that 10 kilograms is the same as 22 pounds. We can also use the proportion method. Again, we're going to take 10 kilograms and find out how many pounds it's equal to. We first have to find our conversion factor, and we should know that 1 kilogram is equal to 2.2 pounds. We then will set up two fractional relationships between our known relationship, 1 kilogram over 2.2 pounds, and set it equal to our unknown relationship of 10 kilograms to X pounds. We then will cross-multiply 1 kilogram times X pounds equals 2.2 pounds times 10 kilograms. When you solve for X, we will find out that 10 kilograms is the same as 22 pounds. A third method of doing these conversions is dimensional analysis. Again, we're going to change 10 kilograms into an unknown number of pounds. With dimensional analysis, we'll start with our 10 kilograms and we're going to multiply by a conversion factor with the unit we want on top and the unit we're trying to eliminate at the bottom. We do this so that the kilograms cancel and we're left with pounds. We then multiply straight across and simplify, and we discover that 10 kilograms is the same as 22 pounds. The fourth method to do these problems is the formula method. We're going to take 10 kilograms and change it into pounds. We're going to start with our 10 kilograms and divide it by our known conversion factor, keeping the unit the same, the 1 kilogram, and then multiply by the unit we're changing to, the 2.2 pounds. Multiply across and simplify, and we discover 10 kilograms is the same as 22 pounds. Now, we can use these methods of converting to do different types of drug dosage problems. We can do simple conversions, we can do oral dosages, we can calculate parenteral dosages, or even reconstitutions. Let's go ahead and do an oral dosage problem. We have an order of 500 milligrams of Tylenol. We have available 200 milligram Tylenol tablets. The question is asking me to take the 500 milligrams and change it into a specific number of tablets. If we look at our conversion factor, it tells us the relationship between milligram and tablets. Each tablet has 200 milligrams, and you can set that relationship up in any of the three ways we looked at, just depending on how you do your calculations. We then would set up our calculation. We did ratio. We put our known, 1 tab to 200 milligrams, to our unknown, X tab to 500 milligrams. Proportion, we would set up fractional relationships. Dimensional analysis, we start with our order and set up a multiply by a conversion factor to cancel out milligrams and give us tablets. In the formula, we take the dosage ordered of 500 milligrams over what's on hand, 200 milligrams, times the way it's delivered, 1 tablet. It doesn't matter which method you use, all 4 methods give you the same answer of 2.5 tablets. We can also solve oral dosages that use more than one conversion. If we have an order of Dilantin, grain 1, by mouth 3 times a day, we have available Dilantin 30 milligram capsules. The question needs me to take the order of grain 1 and figure out how many capsules I need to give the patient in order for them to receive grain 1 of Dilantin. If we looked at the conversion factors, they don't give us a relationship between capsules and grains. However, they do give us a relationship between milligrams and capsules, and we know a relationship between grains and milligrams. We should have memorized that grain 1 equals 60 milligrams, and we can tell from the problem that 30 milligrams is equal to 1 capsule. So our first step would be to convert our ordered dosage of grain 1 into milligrams using our known conversion factor of grain 1 equals 60 milligrams. We then have a conversion factor of 30 milligrams to 1 capsule so that we can change 60 milligrams into capsules. All 4 methods will give you the exact same answer of 2 capsules. We can also use these methods to solve parenteral dosages. Let's say we have an order of Visceral 20 milligrams IM every 4 hours as needed for nausea. Our supply is a 10 milliliter vial of 25 milligrams per milliliter. The question wants us to find out how many milliliters we're going to have to give our patient so that they receive 20 milligrams of medication. Our conversion factor needs to give us a relationship between milliliters and milligrams. If we look at the supply, they give us milliliters twice, 10 milliliter vial and 25 milligrams per milliliter. The conversion factor we want is the one that shows the relationship between milligrams and milliliters. 25 milligrams is equal to 1 milliliter. The 10 milliliter vial just tells us how big the bottle is that we're dealing with. We then will convert the 20 milligrams into milliliters by using our conversion factor that we just saw. 25 milligrams equals 1 milliliter. Doesn't matter which of the 4 methods you use, you will still get 0.8 milliliters. Reconstitutions are drugs that are packaged as powders and must be reconstituted before administered to a patient. These are normally the ones you add a liquid to and shake up before you give it out to a patient. The label will tell you how much drug is in the vial or ampoule, either in grams or milligrams or grains. It will also tell you what you're going to use, what kind of liquid that you're going to use to dissolve the powder. Then it will tell you the strength of the resulting solution. When you're calculating the amount of medication you need to give the patient, you're only worried about the strength of the resulting solution. Keywords to look for are the solution yields, or it will result in. Something like that that shows that this is what's in it after it's already been mixed. For example, let's say we have a patient who needs 25 milligrams of gentamicin IM. The label tells us to add 1.3 milliliters of sterile diluent to yield 50 milligrams per 1.5 milliliters. How many milliliters of reconstituted solution should we give? Well, the question is asking me to take the 25 milligrams ordered and change it into milliliters so that we can give it to the patient. If we look for a conversion factor relating milligrams to milliliters, we can see that this medication yields 50 milligrams per 1.5 milliliter. That's after we've already mixed it, added the liquid to it, and shook it up. The result is 50 milligrams per 1.5 milliliters. That's the only information we need when we calculate this drug dosage. And again, it doesn't matter what method you use, we will discover that to give the 25 milligrams, we're going to have to administer 0.75 milliliters. Now don't forget, with tutoring services, we have a bunch of hallway handouts that you can pick up for more practice. One is called How to Solve Drug Dosage Problems. Another one is Drug Dosage Practice Problems. These also can be downloaded online from our helpful handouts link. And don't forget, if you feel you need it, we do have one-on-one tutoring available in our offices at both campuses.